This is the second video on chapter 2, that is exponents and powers. In the first video, we have completed till question number 6. So let's start with question number 7, that is, show that x to the power p divided by x to the power q whole to the power r into x to the power q divided by x to the power r whole to the power p into x to the power r divided by x to the power q whole x to the power r divided by x to the power p whole to the power q equals to 1. So what we'll do is we'll multiply the exponents both to the numerator and denominator. So we'll have x to the power pr divided by x to the power qr into x to the power qp divided by x to the power rp into x to the power rq divided by x to the power pq. Now see, x to the power pr in the numerator and x to the power rp both are same, because if I write p into r or r into p, it is same. Whether we write 2 into 3 or 3 into 2, the result is same. So we can cancel this x to the power pr and x to the power rp. Similarly, we can cancel this x to the power qp and x to the power pq. And also we can cancel this x to the power rq and x to the power qr. So everything is getting cancelled. So what is remaining is 1. Now here, there is also an alternative method which you can apply. Since here the common base is x, the one which is in division, we will write the exponents in subtraction, and the one which is multiplied, we can write the exponents as addition. So here, taking the base x as common, we can write x to the power pr, and since qr is in division, so we'll write minus qr. There is a multiplication sign, so we'll write plus qp minus rp plus rq minus pq. Now here we have plus pr and minus pr. So plus 1 minus 1 is equals to 0. Similarly, minus qr plus qr or rq will get cancelled, again 0, and plus qp and minus pq will get cancelled, that is 0. So in the exponent will have 0, and we know that any number to the power 0 is equal to 1. So here we have x to the power 0, which is equals to 1. Therefore we can say that the LH is equals to RHS. Question number 8, x to the power a plus b whole to the power a minus b into x to the power b plus c whole to the power b minus c into x to the power c plus a whole to the power c minus a equals to 1. Now here a plus b into a minus b is the expansion of a square minus b square. So instead of writing a plus b into a minus b, we can write it as a square minus b square minus c square, and so on. So here in the next step we have written it as x to the power a square minus b square into x to the power b square minus c square into x to the power c square minus a square. Now see, since there is minus in the exponent, can't we write it in division form? So yes, we can write it in division form. So we have written it as x to the power a square divided by x to the power b square into x to the power b square divided by x to the power c square into x to the power c square divided by x to the power a square. Now again, as you can see, x to the power a square in the numerator and x to the power a square in the denominator will get cancelled. Similarly, x to the power b square and x to the power b square will also get cancelled, and x to the power c square in the numerator and x to the power c square in the denominator will get cancelled. That is equals to 1. Another alternative, as I have taught in the last previous sum also, that is taking x common. If I write all these terms, all the exponents, that is a square minus b square, there is a multiplication in between, so there is plus b square minus c square. plus c square minus a square. So as we can see, we have plus a square minus b square plus b square, which is getting cancelled, minus c square plus c square, again getting cancelled. So what we have, x to the power 0, that is equals to 1. Therefore our LHS equals to RHS. Question number 9. Show that x to the power a divided by x to the power b whole to the power a square plus bc plus b square into x to the power b divided by x to the power c whole to the power b square plus bc plus c square into x to the power c divided by x to the power a whole to the power c square plus ca plus a square equals to 1. Now see, here we have xa divided by xb. Can't we write it in another form, that is x to the power a minus b? So for every division form, we will write the exponents in subtraction. So in the first step, what we have written, x to the power a minus b whole to the power a square plus ab plus b square into x to the power b minus c whole to the power b square plus bc plus c square into x to the power c minus a whole to the power c square plus ca plus a square equals to, ca plus a square. Fine. Now see, this a minus b into a square plus ab plus b square, it is the expansion of a cube minus b cube. Similarly, b minus c into b square plus bc plus c square is the expansion for b cube minus c cube. So here, instead of writing a minus b into a square plus ab plus b square, we will write it as a cube minus b cube. So next step, we have written it as x to the power a cube minus b cube into x to the power b cube minus c cube into x to the power c cube minus a cube. Now take x common, and in the exponent we'll write a cube minus b cube plus b cube minus c cube plus c cube minus a cube. And as we can see, we have plus a cube minus a cube, which will get cancelled, minus b cube plus b cube, which will get cancelled, and minus c cube plus c cube, which will get cancelled. So what we have, x to the power 0, which is equals to 1. Therefore our left hand side is equals to right hand side. Question number 10. 1 divided by 1 plus x to the power a minus b plus 1 divided by 1 plus x to the power b minus a. Now this denominator x to the power a minus b, can we write it in division form? So let us write in division form. That is 1 divided by 1 plus x to the power a divided by x to the power b plus 1 divided by 1 plus x to the power b divided by x to the power a. Now in the first case, we can take x to the power b as the LCM. So what we'll have, 1 divided by 1 plus, not 1, it will become x to the power b. 1 into x to the power b will become x to the power b plus x to the power a whole divided by x to the power b plus 1 divided by, here again we'll take x to the power a as the LCM. So what we'll have, x to the power a plus x to the power b by x to the power a. Now we know that a denominator's denominator will become a numerator. So this x to the power b in the denominator means denominator's denominator will become our numerator in the next step. So we have written x to the power b as the numerator divided by x to the power b plus x to the power a plus, again here x to the power a will become the numerator. So x to the power a divided by x to the power a plus x to the power b. Now we can see that in both the terms we have x to the power a and x to the power b common. So we can take this as common LCM, and as a result the numerator, we will add the numerator. This will give us x to the power b plus x to the power a. Now we can see that the numerator and denominator are same, so it will get cancelled. So the result is equal to 1. Question number 13. a to the power 7 plus 2n into a square to the whole to the power 3n plus 2 divided by a to the power 4 whole to the power 2n plus 3. Now, wherever there is addition in the exponent, we will put multiplication sign and write it with the base a. So here we have started with a to the power 7 into a to the power 2n into, here we have multiplication of exponent. So we have written it as a to the power 2 into 3n is 6n. So a to the power 6n. Again there is plus 2, so we can write it as into a to the power 2 into 2, that is a to the power 4. Below in the denominator, a to the power 4 into 2n, that is a to the power 8n. Instead of plus, we will write it as into a to the power 4 into 3, that is 12. So here first we will take all the n variables together and the numericals separately. So first we have written a to the power 2n plus 6n, and 8n is below in the denominator, that is in division form. So we have written it as minus 8n. Again a to the power 7 plus 4, and here 12 is in the denominator, that is division form. So we've written it as minus 12. So here we'll get a to the power, see 2n plus 6n, that is equals to 8n. So we've written it here as 8n minus 8n. And 7 plus 4 is 11. So here we'll get a to the power 11 minus 12. So plus 8n minus 8n will get cancelled. So we'll have a to the power 0, which is equals to 1. And a to the power 11 plus 11 minus 12 is a to the power minus 1. So 1 into a to the power minus 1 is a to the power minus 1. And how can we write a to the power minus 1? We can write it in fraction, that is 1 by a. Next, question number 14, 3. 64 to the power 2 by 3 plus cube root of 125 plus 3 to the power 0 plus 1 divided by 2 to the power minus 5 plus 27 to the power 2 minus 2 by 3 into 25 by 9 whole to the power minus half. Now, we have to write the 64 in such a way that the fraction 2 by 3, in the fraction 2 by 3, the 3 gets cancelled. So if I factorize 64, I can write it in the cube form, that is 4 cube is equals to 64. So I have written it as 4 cube whole to the power 2 by 3 plus cube root of 125. Now if I factorize 125, we know that 5 cube is 125, that is 5 into 5 into 5. So I have written it as 5 cube. And since here the question has given us a cube root, so how do we write a cube root in exponent? We write it in fraction. So that is why we have written it here as 1 by 3. 3 to the power 0 will become 1 plus 1 divided by 2 to the power minus 5. Now in the denominator there is a negative exponent. So we know that to make it positive, what we'll do is in the denominator we'll write it in fraction. So it will become 1 divided by 1 by 2 by 5. Now denominator will become the numerator. So 2 by 5, 2 to the power 5 will come in the numerator as positive value plus 27 to the power minus 2 by 3. Now can we write 27 in a cube form? That is 3 cube. So I've written it here as 3 cube whole to the power minus 2 by 3 into, now 25 by 9 whole to the power minus half. To convert this minus half, the power minus half into plus half, we will have to reciprocal the number, that is 25 by 9 will become 9 by 25. Therefore, the exponent will convert into positive sign. So here, this from the first term, that is 4 cube into 2 by 3. So 3 and 3 will get cancelled. So we'll have 4 square. Again, 5 to the power 3 into 1 by 3. 3 and 3 will get cancelled. So we'll have only 5. Plus 1 is written as plus 1. Plus 2 by 5. 2 to the power 5 is written as plus 2 to the power 5. Plus 3 to the power 3 into minus 2 by 3. Again 3 and 3 will get cancelled. So what is remaining is 3 to the power minus 2 into 9 by 25 can be written as 3 by 5 whole square into 1 by 2. So again 2 and 2 will get cancelled. So what will have? Only 3 by 5. So 4 square is equals to 16 in the next step. Plus 5 plus 1, that is plus 6. Plus 2 to the power 5 will become plus 32. Plus 3 to the power minus 2 can be written as 1 by 3 to the power 2. Now 1 by 3 square means 1 by 9. So I've written it here as plus 1 by 9 into 3 by 5. Now adding all this number, that is 16 plus 6 plus 32, will give us 54. Plus, if I multiply this 1 by 9 into 3 by 5, that is equals to 1 by 15. So I've written it here as plus 1 by 15. That is equals to 54 1 by 15 as a mixed fraction. Question number 15, 2 by 5 whole square whole to the power 4 whole to the power x plus 2 is equals to 2 to the power 5 whole to the power minus 2 whole to the power minus 1 x minus 1 whole to the power minus 3. Now let us start solving it from the first and the second bracket. So here 2 by 5 whole to the power, so 2 and 4, if I multiply 2 and 4 we'll have 8. Again whole to the power x plus 2, and in the right hand side we'll have 2 by 5 whole to the power, so minus 2 into x minus 1, so we'll have minus 2 plus 2 and whole to the power minus 3. So here we'll have 2 by 5 whole to the power 8x plus 16, that is we have multiplied 8 into x plus 2, it is 8x plus 16 equals to 2 by 5. Now multiplying minus 2x plus 2 by minus 3. So that will give a minus 2x into minus 3 is plus 6x, and minus 3 into plus 2 is minus 6. So here we have written it as 2 by 5 whole to the power 6x minus 6. Now as we can see, 2 by 5 is common in both LHS and RHS. So here we will eliminate this 2 by 5 and we will only equate the exponent to find the value of x. So we have written it as 8 plus x equals to 6x minus 6. So 8x minus 6x is equals to minus 6 minus 16, which is equals to 2x. That will give us 2x equal to minus 22. So therefore the value of x is minus 22 divided by 2, that is equals to minus 11. Here are some homework given to you. I hope you can do this sum and you have understood this chapter properly. Before I end, I like to address a query which was asked in the previous chapter, that is whether the LCM method can be used to find out 3 or 4 rational numbers in between two given rational numbers. So the answer is yes, you can apply the LCM method even when you are trying to find out least number of rational numbers in between two given rational numbers. So that's all for today. Thank you.